Okay, welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. In this video, we are going to discuss the 89th problem of the lead code, that is gray code. Now, the problem says that you have been given an integer n. You have been given an integer n, and for that n, you have to give me a sequence which contains 2 to the power n integers. That is, if n is equals to 2, you have to give me 2 to the power 2 integer. That is equals to 4 integer array. Okay, the size of the array will be 4. Now, what are the properties of that array? Suppose my array is ARR, right? Okay. The properties of array is that it should contain, like, all the integers within the array should be in the range 0 up till 2 to the power n minus 1. For n equals to 2, it will be 0 to 3, right? This is my first condition. Second condition says first integer is 0. First integer is 0. Okay, no problem with that. Third says the integers appears no more than once. That is, the integer should appear exactly once. If the sequence is of length 2 to the power n and it appears no more than once, then that is only possible if each value from 0 to 2 to the power n minus 1 appear exactly once, right? This is our conclusion up till now. Now, the binary representation of every pair of adjacent integers differ by exactly 1 bit, and the binary representation of the first and last integers differs by exactly 1 bit. Let us understand what does it say. What does it mean? So, in the given example, we have been given that for n equals to 2, 0, 1, 3, 2 is a valid sequence. For n equals to 2, that means 2 to the power 2, 4 integers I want, right? The sequence given to me is 0, 1, 3, 2. 0, 1, 3, 2. Now, if I write the binary representation, it will be 0, 0, 0, 1, 1, 1, and 1, 0, right? This is a binary representation. Okay. While I'm going from here up till here, you can see only one bit has changed. This 0 has actually converted to this 1, right? Only one bit has changed. When I'm going from here to here, you can see this only 0 bit has changed to 1, right? Only one bit changed. Now here 1 1 to 1 0, again this bit has changed to 0, so 1 bit again, right? Now not only this, I will have to compare this with this, that is 1 0 to 0 0, something sort of a circular array. So you can see 1 0 to 0 0, again this is getting changed, only one bit is getting changed, right? Exactly one bit should always change between two adjacent numbers and the last and the first. These are the last 2 points of the question. So I hope you are clear with the input and output scheme of the question and ready to move to the approaches to solve it. Okay. So what is the approach you can do? So first, we have been given n. We know the sequence will be of length 2 to the power n. I say the brute force approach says make all permutation of the array 0 up till 2 to the power n minus 1. Make an array 0, 1, 2, 3, 4 up till 2 to the power n minus 1 and make all the permutation. Whichever permutation fits the above all the condition, whichever condition fills all the condition, return that as your answer. That is my first approach. Okay, that is actually very clear, but the time complexity will be actually very great. Why? Because the number of elements are 2 to the power n elements, right? And the permutation is also an exponential type. So it will be 2 to the power 2 to the power n, something sort of this, right? Which is very bad. Believe me guys, which is a very bad time complexity. We will have to devise something that takes little less complexity. Okay. So let us try to make a sequence with the base case, right? What is the smallest case possible? For n equals to 1, right? For n equals to 1. N equals to 1, that means my integers will be in range 0 to 2 to the power 1 minus 1. That means it will be 0 and 1. Now, if I try to make an array, it will be 0, 1. This will be my answer for n equals to 1. Why? Because my first integer is 1 and I know every integer appears exactly once. The only integer left with me is 1. So it will be 0, 1. You can see all the properties are following here, right? Now, moving on to n equals to 2, a slightly bigger test case. When I move to n equals to 2, I say that I have to put in 0 to 2 to the power 2 minus 1. That is 0, 1, 2, 3. These elements are to be fitted. I know that the first element will be 0, which is given in the question itself. The first element is 0. After my first element is 0, I have the choices of, let me write the binary representation. It will be 0, 0, it will be 0, 1, it will be 1, 0, and it will be 1, 1, right? Now, 0, 0 can change to 1 or it can change to 2. because only these two will apply, that only one bit is changing, right? So 1 is an option, 2 is an option. Let us move with 1. Why I'm choosing 1? I'm choosing 1 because I previously got 0 1 as a subsequent, so I say let us continue with 1 only. Okay, I say 0 1, that is 1, right? And essentially it is 0 1. Now as I move forward, 0 1 has got only 1 1 as choice. 1 0 is not a choice, because if I'm going to 0 1 to 1 0, I'm changing both the bits. This bit is getting toggled and this bit is getting toggled, right? Only 1 1 is the option with me. So we'll have to put 1 1 here, that is 3. And after putting 1 1, the only element remaining is 1 0, and you can check 1 0 is getting correct with 1 1 also, and 1 0 is getting correct with 0 0 also, right? So 0 1 3 2 is my answer for n equals to 2. The conclusion is derived. Now if I try to say you that are you observing any similarity between this sub array and this array, if I write them something like this: 0 0 0 1, this is my first one. Second one is 0 0 0 1 1 0 1 1. You can see the first two elements are equal, right? Now you can also see that the last two elements are also in some sort of equal. How am I saying that? If you see the last bit is 0 1, it is again 0 1, right? Only this bit is getting changed, only the MSB is getting changed. Let us move forward and let us try to make the relation a little concrete. Okay, n equals to 3, right? N equals to 3, number will be in the range 0 to 2 to the power 3 minus 1, that is 0 to 7. 0 to 7. Let us start. The numbers will be 0 0, let us 0 0 0 0 0 1 0 1 0 0 1 1. Now moving forward, 1 0 0 1 0 1 1 1 0 1 1 1. These are the numbers I have in hand. I know that the first number is 0 0 0, so I put 0 0 0 here. Oh sorry, I put 0 0 0 here, that is the number 0 here. This has been ruled out. Now 0 0 0, I can only move to this bit or this bit or this bit. These are the three options. Okay, I'm favoring the subsequence as first again. I'm saying 0 1 here, so let us try to move 0 1 only, because I'm trying to develop a pattern. So I'm saying 0 0 1. Alright, 0 0 1, so it is I'm essentially putting 1. After I put 1, I have already put it 1, and after I put 1, the only options remaining with me are, I can actually put 0 1 1, right? 0 1 1 and 1 1. No, not this. I am saying that it is 0 0 1 can change to 1 0 1 as well, right? 1 0 1 as well. Okay, these are the two options. I am saying that I have already tested the 3 and 2. Let us place those bit only. 0 0 1, that is 0 1 1 0 1 0, right? That is, I have ruled out this one, I have ruled out this one, I have ruled out this one. These are the remaining ones. These are the remaining ones. Now moving from 0 1 0, can I put 1 1 0 with it? Can I put 1 1 0 with it? Why I'm doing it? Why I'm doing it? I'm trying to make the relation as I stated it, right? These two bits are actually getting changed because of only this MSB, right? Only because of the MSB. That is my case here, right? So it will be, I'm saying that for 2, that is for 0 1 0, I'm putting 1 1 0. I'm only changing the MSB, and 1 1 0 corresponds to 6. Okay. After putting 1 1 0, I will try to put MSB changed of 0 1 1. That is 1 1 1. I will try to put 7. Okay. After moving with this operation, I will move to 0 1 0 0 1. I will make it 0 1 0 1, and that will be 4 plus 1, that is 5, and the last will be 1 0 0. It will be 4. Are you guys able to understand what I am doing? I am saying place all the bits with MSB as 0, and then consecutively their bits with the MSB equals to 1. That is my whole approach here. So you can see, you can compare that all the properties are getting followed in this bitwise sequence, right? You can also extend it. How I'm going to extend it? Now, I would like to draw your attention to n equals to 4, because this is a rather large subcase, and I will try to draw the recursion that I will be using, right? So n equals to 4, that is 0 to 2 to the power 4 minus 1, that is 0 to 15. I have to fill out 0 to 15. So as usual, number of bits is 4, right? Number of bits is 4. So first let me draw out all the tension. So I will put out 0 0 0 0, right? And for the first case, that is n equals to 1, I already put out 0 0 0 0 1. This was my test case, right? That is 0 and 1 are already in the sequence. Moving forward, I will take the MSB of this, that is, I will change this MSB. it will become, first I will put the MSB of this and then this, right? Okay, so it will become 0 0 0 1 1, and then it will become 0 0 1 0. Going forward, 0 0 1 has 1 0 has been placed. Now MSB, this MSB has to be changed, right? Moving forward, 0 1 1 0, then this one, 0 1 1 1, then this one, 0 0 1 0 1, then this one, 0 1 0 0, right? Now the last bit, the fourth bit, that will be, I will start with this, that is 1 1 0 0, then 1 1 0 1, then 1 1 1 1, then 1 1 1 0. This is corresponding to this, right? And now 1 0 1 0, I am changing the first bit, 1 0 1 1, 1 0 0 1, and the last one is 1 0 0. Now it is your job to check if all the properties are being taken care of or not, right? So what was my test case? I first put these values, then I multiplicated these values to these two values, and then these four values to another four values, and these eight values to the below eight values, and that is how I got my array, right? So what is my sequence essentially? If I try to write the decimal representation, it will be 0 1 3 2, then this is 6 7, and this is a 1 0 1, that is 4 plus 1, that is 5. After that 4, after that it will be 0 1 2 3, that is 2 to the power 8, that is 8 plus 1 9. After that 8 plus 1 9 plus 1 10. After that 15, moving to 15 minus 1, that is 14, then 10, then 11, then it will be not 9 again, I guess. It is not 9, it is something sort of this. Okay, this is the integer sequence. You can continue, you can change this to binary, right? How will my code work? I will first have to push these two values. So what I am doing is I will make a helper function which will take my current n and my answer which I have to push in. My base case is that if n equals to 1, if n equals to 1, I can surely say answer dot push back. First you push back 0, and then you push back 1, right? And then return, safely return, no problem. But if my n is not 0, if my n is not 1, sorry, if my n is not 1, what is the test case? I will have to move towards n equals to 1 to put this. I will have to move towards n equals to 1 to put these two. Am I right? Am I clear here? I have to move towards n equals to 1 to firstly put these two, and then corresponding to these two I will put the another values, right? So I will just call it for n minus 1. I will call the helper function for n minus 1 and same answer, right? And after my n minus 1 gets called up, I will now I will use these values to make these two values. How? I am saying that, let me say n equals to answer dot size now. N equals, not n, it will be j, answer dot size, right? Answer dot size. So after n equals to 1, that is I have got 0 and 1 in my answer, my n equals size will be 2. And if you see 0 0, that is 0 0 0 1, I have to append 1 1 with 1 0, that is I have to put in this bit. What is this bit? This bit is actually getting 0th bit pushed by 1, that is left by I. So I am saying j equals to answer dot size, that is 2 minus 1. And now I will say for int x equals to n minus 1, that is answer dot size minus 1 to be correct, answer dot size minus 1, I greater than equals to 0, I minus minus. What will happen? I will change this bit and then push it into the answer. So my value will become I left shifted by j values, right? Or with answer of I, right? Answer of I. This is my I, and then answer dot push back value, right? And then I will simply return my answer. This is the only case I have to do, right? This is the only case. Let us try to visualize the dry run. Okay. So here we are. Let us try to start it with f of, not f of, it is helper. Okay. I am using f a short. So for n equals to 4, suppose my data structure will be empty right now for n equals to 4, right? This is by reference. This is sent by reference. Okay. So I'm not writing it here. I will just add it here. I will just add the values here, right? Okay. I will call it for f equals to 4. I will see my n is not 1 right now. I will go to n equals to 3. Okay, I will call the other function f of 3, which will call f of 2, which will call f equals to 1. Now f equals to 1, this base case will arise. Answer dot pushback 0. I will write 0 here. Answer dot pushback 1. I will write 1 here. Right? Return. Okay, return. This function will return. Now f equals to 2 will run. My n is 2 here. I say I equals to answer dot size. What is my current size of answer? It is 2. I say my I is equals to 2 right now. Right? Okay. And I say while I is greater than equals to 0. Right? Let me write it with another pen. I'm saying my I equals to 2, right? My I equals to 2, right? It will be minus 1 here. I equals to 2 minus 1, that is 1. What I'm saying is while I is greater than 0, while I is greater than 0, 1 is always greater than 0, value equals to answer of I plus, or 1 left shifted by n minus 1 position. Okay, my n is 2 here, my n is 2. 1 left shifted by n minus 1, that is, and 1 left shifted by 1, that will, it will become 1 0, right? It will become 1 0, and answer of I is, this is 0 index, this is 1 index. Answer of I is 1, that is 1, 0 1, and this 1. If I take the OR, it will become 1 1, that is 3. So I push in 3, I push in 3, I push in 3, and I minus minus. I will change to 0. After I will change to 0, I will do it for the 0 as well. I will do it for the 0. What is happening is, I will say my value will be answer of I, that is 0 0 plus 1 left shifted by n minus 1, 0 0 with 1 0. It will become 1 0. I will push in 3 now. I will push in 2, sorry. I will push in 2, and the recursion call f equals to 2 will return. Moving to f equals to 3. Moving to f equals to 3. Now for f equals to 3, what will I do? I will do the same operations. I will start with 2. I will start with 2. Now my n here is 3, so I will push the vector back by 2 position. I will push 1 back by 2. So I have to take OR with 1 0 0 now. For 2, it will be 0 1 0. It will convert to 1 1 0. 1 1 0 is actually, what do is 1 1 0? It is 6, I guess. Okay, 1 1 0 is 6. After 2, it will be going back to 3. After 2, it will be 1 to 3. So 1 1 1, that is 7. After 3, it will go to 1 0 0 1. It will go convert to 1 0 1. 1 0 1 is 1 0 1 is, it is 1 plus 4, that is 5. Right? After 0 1 0 0 1, it will go to 0 0 0, which will give me 1 0 0. After 1 0 0, what is the 1 with 0 0? It is 4. Right? After putting in 4, I will go to the 4, and I will do the same operation for this side, and I will get the complementary MSB as 1, right? And I will get the all the other 8 elements. You can count 1 2 3 4 5 6 7 8, and 8 below, that is 16 elements in total, and this will be my code. Okay, this will be my code. So hope you were able to understand, and let us now move to the coding section. So before starting to the code, I would like to request you to please subscribe to my channel and give me a like button as much as possible, because it really motivates me, right? And please connect with me on social media handles on my Instagram and my LinkedIn, right? I am attaching the Instagram and LinkedIn handles on the description below. Let us start to code. First, I will create an answer to send it by reference. This will store my all the values, and now I will call the function f and send in my n and answer. After it, I will say return your answer. This is the only operation I have to do in the driver code. Rest of the things will will be taken care by MIF. What will I do? I will say that void f, it is taking my int n and vector of int answer. Right now, base case is that n equals to 1. If n equals to 1, answer dot push back 0, answer dot push back 1, and then simply return. Now I will call the function for n minus 1, f of n minus 1 with answer. Now, while my I is greater, oh, I will have to make my I, right? Sorry. I am saying my int I equals to 0, equals to answer dot size minus 1. While I is greater than equals to 0, I will say my value becomes 1 left shifted by n minus 1 position, and simple OR with value at that I index, right? And then answer dot push back that value, right? And return to mark the ending of the function. Let us try to compile and run it. Hope it will run fine. There has been some mistake, guys. There has been some mistake. What is the mistake? Oh, it will be answer of I, sorry. Let us try to compile and run it now. It is not running fine. What is the matter here? The matter here is I minus minus. Let us try to compile and run it now. Sorry for the typing mistakes and Okay, it is getting accepted. Let us try it for submit as well. Hope it will run fine. If it runs fine, please subscribe to my channel. Oh, thank you, it got. Okay, thank you for watching and have a nice day. We'll meet tomorrow with a new question.